In Colombia's Cerrejón region, a team of scientists and paleontologists was excavating deep within a coal mine. This coal mine was actually formed from a 60-million-year-old rainforest. That's why they were searching for the remains of ancient plants and animals there. This place was part of a mysterious past, hidden from the world, concealed by the earth within its layers. During the excavation, experts found a strange object deep within the rocks. When the dirt was cleared away, it turned out to be nothing other than a bone. Someone said it was a crocodile bone. Others began calling it a turtle bone, while some believed it to be the trunk of an ancient tree. But this very bone later led science on a journey into a world where the largest snake ever known lived, Titanoboa. This was no ordinary snake. It was 10 times heavier than today's green anaconda and longer than a passenger bus. It was so heavy that if it tried to crawl on land, it could die under its own weight. So where did it actually move? A simple bone led experts to a chapter of Amazon's history where the map was completely different. What was the real reason behind Titanoboa's giant size? How did it hunt? And what finally caused its reign over the Amazon forests to end? Welcome back to Money Basics Explains videos. The discovery of Titanoboa was no sudden event. Rather, it began in 1994. A local geologist, Henry Garcia, saw a peculiar object in the Cerrejón mine that looked like part of a tree branch. At the time, no one paid much attention to it, and it was stored in a special box. Nearly a decade later, in 2002, another geologist, Fabiani Herrera, found a similar fossil here. These geologists were actually researching ancient flora to understand what the world's first tropical rainforests looked like. The real twist in this story came in 2007 when these fossils were sent to the Florida Museum of Natural History. There, it was discovered that it was neither a tree branch nor did its structure match a crocodile's spine. But when they compared its structure with the bones of today's anacondas and pythons, the surprise was immense. This bone was 3 times larger and thicker than an anaconda's bone. Experts immediately identified it as a snake's vertebra. You can guess for yourself. On the right is the bone found in the coal mine, and on the left is an anaconda's vertebra. In the world of science, size matters a lot, and Titanoboa broke every previous record. Experts used mathematical models based on this vertebra to estimate the snake's length. They observed that in snakes, the size of the vertebrae is directly related to their total length, meaning the size of a snake's vertebrae can indicate its total length. Based on these calculations, the estimated length of the snake from this vertebra was 42 to 50 feet, roughly twice as long as today's anaconda.
Titanoboa wasn't just long. Its thickness was comparable to a large man's waist, and its weight was as much as a sedan car, about 1,200 kilograms, or 10 times heavier than an anaconda. A weight of 1.2 tons is impossible for any land snake today. This discovery caused a worldwide sensation because, in reality, this was the king of snakes, later named Titanoboa. The real question wasn't just how big it was, but why was it so large? Why don't snakes grow that big today? The answer lies in the climate. Snakes are ectothermic, or cold-blooded animals. Humans can generate internal heat to keep their bodies warm, but snakes depend on environmental temperature for their warmth. A simple principle of biology is that the warmer the environment, the faster the metabolism of cold-blooded animals. Faster metabolism means more strength, better digestion of food, rapid growth, and the ability to support a larger body. Titanoboa's discovery presented experts not only with a new snake, but also with a thermometer of that era's climate. Titanoboa's giant body was living proof that 60 million years ago, the temperature in Colombia's environment was much higher than today. During that period, Earth's climate was so warm that temperatures remained above 32 degrees year-round, day and night. If the average temperature was so high, the humidity must have been extreme, so high that breathing might have felt heavy. It was a dense forest that never cooled down. This constant heat gave Titanoboa the ability to grow so large. Today's Amazon rainforest, which feels quite humid and warm to us, might have been too cold for Titanoboa. If it were alive today, it probably couldn't survive in this rainforest because the energy required to sustain such a massive body could only be obtained in that intense heat. Now, clearly, to keep such a large body alive, it needed a lot of food. The question arises, how did Titanoboa hunt? Did it chase its prey on land like the monsters in Hollywood movies? Absolutely not. Such a large and heavy body made it difficult even to crawl on land, let alone hunt. Gravity worked against its weight. The longer a snake is, the more it clings to the ground, meaning more friction. Research revealed that Titanoboa was very sluggish. That's why it was not a land hunter, but an aquatic predator. It behaved much like today's crocodile. It spent most of its time in swampy water because the water supported its heavy body, allowing it to float and move with buoyancy, making its weight feel lighter and enabling agility. In deep, swampy areas, it would lie in ambush, with only its eyes and nostrils visible above the water. It was an ambush predator, one that attacks by surprise. It didn't chase its prey, but waited patiently in ambush for long periods, hours, maybe even days without moving. Its body camouflaged with the water's color so well that prey wouldn't even realize its presence. And as soon as an animal came to the edge of the water to drink, Titanoboa would strike with lightning speed. Scientists used biomechanical models to estimate that when Titanoboa constricted its prey, it exerted a pressure of over 400 psi. This pressure is so immense that it's like having two African elephants standing on your chest. Titanoboa didn't wait for its prey to suffocate. Instead, such pressure would instantly break bones and stop blood circulation. The prey would be dead in the blink of an eye.
But what did it eat? To sustain such a giant body, it needed a lot of food. In this tropical forest of 60 million years ago, Titanoboa's favorite meals were giant turtles and ancient large crocodiles. Yes, during that time, there were turtles as large as over 8 feet, the size of a snooker table. Titanoboa could clamp such turtles in its jaws and crush their hard shells. Its teeth weren't designed for catching fish, but for crushing thick bones. Similarly, the crocodiles that dominate forest ponds today were prey for Titanoboa back then, as even larger crocodiles existed during that era. All these facts indicate that Titanoboa was the predator of predators and the unmatched king of the Amazon in its time. Now, you might wonder, if its thickness was like a healthy human's waist, how did it swallow such a large turtle? Here, let me tell you that in snake discoveries, the biggest challenge is finding their skull. A snake's skull is made of very delicate bones that break down easily after death. For the first few years after Titanoboa's discovery, experts only had vertebrae, making it difficult to accurately understand its face and hunting methods. But then, in 2011, an intern named Jorge Moreno Bernal found Titanoboa's skull in Cerrejón. It was a once-in-a-lifetime discovery. This skull proved that its jaw could dislocate like an anaconda's, allowing it to swallow something 3 times larger than its head. Its brain was very small, but its senses were sharp. It had pit organs that could detect the heat of other animals' bodies, enabling it to hunt even in the dark. Also, remember that water wasn't just a hunting medium for Titanoboa, it was essential for its survival. If such a large body were entirely on land, it would collapse under its own weight, and its internal organs would rupture. Water provided support, allowing it to lighten its load. Thus, Titanoboa's life was in perfect balance. Heat gave it strength, and water reduced its weight. It was a marvel of nature, perfectly adapted to its environment. But here's the question. If it was so perfect, so powerful, and had no predatory enemies, how did this king of the forests disappear? Why don't we see them today? The answer is simple, yet tragic. The world changed, but Titanoboa couldn't adapt in the same way. After the Paleocene era, the Earth's climate gradually began to cool. For us humans, a few degrees up or down is ordinary, but for a cold-blooded giant, it was a death sentence. As you learned earlier, Titanoboa's metabolism depended on environmental warmth. As the cold set in, its metabolism slowed down. Its digestion process became longer, and its strength diminished. It was no longer as agile, nor could it catch prey easily. It wasn't just the drop in temperature, the entire ecosystem changed. The swampy areas of the rainforest, perfect for Titanoboa's habitat, gradually dried up. Swamps diminished, and along with all this, mammals drove the final nail in the coffin. Mammals began to proliferate worldwide, and the prey that once belonged to Titanoboa was now divided among other animals. In no time, everything became insufficient for the world's largest snake. No swamps, no warm climate, and no prey remained. Just a few degrees of cooler weather turned the world's largest snake into a part of history. We hope you'll like and share this Money Basics Explained TV video generously. Thank you very much for your loving comments. See you in the next amazing video.